My name is John Smith. I'm the founder and president of Advanced Paving Technologies. So how many of us have been stuck in this situation here? It's very frustrating, isn't it? Thankfully, California SB1 and the Federal Infrastructure Bill are starting to direct billions more at the problem. But it's not enough. We're still losing ground on the current $420 billion backlog in road rehabilitation needs. Current paving machines are based upon a design that's over 80 years old. Yes, they make them bigger and flashier now, but we're still basically fixing our roads today with the equivalent of a Model A Ford. It's a simple design. They dump a bunch of asphalt in front of a big flat plate called a screed that extends the entire width of the paving machine. This screed can only deliver a flat layer of asphalt, which makes it totally inadequate to compensate for bumps, dips, and ruts that are common to all roads that require rehabilitation. The industry's solution is to grind or mill down every square inch of the road flat, so the flat delivery method of current paving machines can be effective. They then haul this material away, they remix it, and they haul it back again to repave the road again. Unfortunately, this scorched earth approach is very slow, costly, and dirty. So why are we doing it this way still? Well, most road construction is driven by government bureaucracies, which has allowed the industry to stagnate. That's why we don't get the same level of innovation that you see in the automotive industry, and why we're still fixing our roads today with the same tools we've always been doing it. A paving machine design that's over 80 years old. Patents for this design ran out decades ago, leaving the industry wide open. And while no other manufacturer is currently developing a true 3D asphalt paving machine, we have already obtained the patents in the US and major international markets. So how does this technology work? Well, first, we use LiDAR laser scanners to obtain a detailed 3D topographical profile of the surface to be paved. We then design a compensating 3D layer that will address any surface deformations that are found. We then deliver that shaped layer with our patented next-generation 3D asphalt paving machine. Instead of a flat screed, we utilize what we call a variable screed to incrementally deliver asphalt across the entire paving surface, placing more material over the depressions and less over the bumps, so when everything fully compacts, will level out to form the smooth, flat driving surface that is desired. So what are the benefits? Well, first and foremost, it's going to produce a better road. By intelligently delivering asphalt precisely where it's needed, we'll be able to produce a smoother, longer-lasting road, so we don't have to keep coming back and fixing them over and over again. We'll also be able to reduce milling by at least 50% to complete jobs faster. This will reduce the labor and equipment costs, as well as traffic control measures, to realize a cost savings of up to 30%, making our method cheaper. And less milling and will reduce the carbon footprint of the road construction industry, while also substantially reducing traffic congestion, making our method a lot cleaner. So here's a typical road damage in the form of severe rutting. Normally the road would be completely milled down. Instead, we target just those areas where the damage occurs. We then deliver our 3D shaped overlay. Once it's fully compacted, everything levels out, and we complete the job without having to rip up the whole road. With this technology, we can build better roads and deliver them faster, cheaper, and cleaner. Every year in the US alone, more than 90 million tons of asphalt is reprocessed in road construction. It takes a huge amount of taxpayer money and energy to sustain this process. And worst of all, it has a substantially negative impact to the environment. Based upon that 90 million tons, with our technology, we can reduce CO2 emissions equivalent to taking more than 5 million vehicles off the road. This really is game-changing technology. So what have we accomplished so far? In 2020, we received a National Science Foundation grant and worked our way through our seed round. We then built our first prototype, the AP Series 1 trench paver. AP for adaptive paving, in that we adapt the delivery of asphalt to the surface deformations. We then performed multiple paving tests up at UC Davis as part of our NSF grants. During this process, we proved that we could address surface deformations to more than twice the acceptable Caltrans single-pass paving limit, all while providing the uniform compaction and the low air void content that is necessary. We have since applied for our NSF Phase 2 grants, and we can get up to $1.5 million from that later this year. We've got a great team put together with excellent technical, financial, and industry advisors, as well as the backing of the National Science Foundation. So how are we going to get this to market? We're going to start out small with a modular trench paving system that attaches to a typical tractor. This way we can quickly get our product out into the field to demonstrate the benefits before we start scaling up into the commercial size paving machines. Currently we're seeking a $1 million investment of a pre-money valuation of $12 million. So at this point I'd like to thank you for your time and open it up for questions.
Thank you. Great innovation. Who's your good customer? Is it public? Is it private? Contractors? Or are you trying to get public works projects?
Both, actually. We're targeting the small to mid-size construction companies, not necessarily the biggest ones, but those who want to take on the big players in the field, and as well as the civil works and DOT departments around the country. Some of them build their own roads, others contract it out. And most of those contractors are right here in California, where SB1 and the infrastructure bill is putting the most money. So we're going to start right here in California and expand out.
You mentioned you completed a seed round. How big was that round? You completed a seed round, right?
Yes.
And how much was your seed round?
For $350,000, and then plus we received $225,000 from the NSF, and that built our prototype and got us through all of our testing to validate it.
I'd like to learn more about your technology. You mentioned most of your presentation talked about programs. So just one suggestion, maybe you cut the program a lot. So since you were short of time, you didn't describe your technology. I'm trying to understand what exactly is your patented technology?
The patented technology is the variable screed, the ability to incrementally deliver asphalt across the paving surface, which is what they can't do right now. And that's why they spend so much time and resources in grinding down a flat surface so that can be effective. So being able to, it's all about precision, putting the right amount of material right where it needs to go.
So next question is who likely, because you mentioned there's lots of different customers, it's just too much. What is your most likely the first field plant looks like?
The construction companies that right now in our interviews, we went out and talked to them, and there are so many construction companies that are having difficulty finding the skilled labor to operate these machines. So what these machines do, they take that human element out of the equation, so we can automatically adjust the delivery of asphalt. So somebody with very minimal training can take this tool in their hands and deliver a final product that is right up to the standards that are necessary.
Yes, also about the technology. So this is very innovative and very efficient. Any other alternative new technology in this space, or you are the only new technology to disrupt the whole industry?
Well, in the fact that we already have the patents on it, there are other companies that are exploring different ways to get around our patents, but right now there's nobody else out there that's doing it, and we feel confident that we're well positioned to lead the way on this technology.
So at the beginning of the presentation you talked about construction, and then you moved to the repair part. Where are you focusing? Building new, repairing old?
It's mainly for road rehabilitation. That's where the greatest benefit comes in. But ultimately, these can be used for new construction because once we attain the ability to control how the asphalt goes down, we can start programming features into the road so we can optimize drainage characteristics or other safety features that make the roads more drivable and more safe to drive on.
And then are you selling servicing, leasing the machines? I mean, it's a capital investment. You need
Correct.
to convince somebody to buy these $500,000. How much is it?
Our Series 1 trench paver is going to start at a relatively modest $75,000. Once we start moving up into the self-propelled paving machines, you start getting into $150,000, $200,000 for the commercial, up to $1.5 million for the large highway class. So that's why we're starting out small, so we can get the technology out there, start demonstrating the benefits, and then we'll scale up to the larger ones.
And then you have to convince your customer to switch.
Correct, but the benefits of being able to produce a better product and doing it faster. California, we know that the roads are so bad out there. They are paying now premium to do these road construction jobs in the middle of the night. So they're paying double, triple times sometimes to decrease the impact on traffic. So we can help the contractors underbid their competitors, and that's the driving point behind purchasing our technology.
Thank you.